Great. So solve an equation. All right. I don't like decimals, I don't like fractions, so I'm going to get rid of my denominators. And the trick is, I'm going to multiply. I want to try to get rid of all my denominators. So I need to multiply by a 3, a 4, and an x minus 2. So this one gets a 3, a 4, and an x minus 2. And this one gets a 3, and a 4, and an x minus 2. Because that's what I need to get rid of all my denominators, right? While this step is ugly, right? The goal, this step is ugly, so the next step doesn't look so bad. Because now when I go through, it's like, okay, stuff cancels. Like this 3 cancels this 3, so I'm left with 4 and an x minus 2. This x minus 2 cancels this x minus 2, so I just get a minus 12.
Wait, you said 4x minus 2?
Oh, x minus 2. I said x minus 2. I wrote 4. Right. And this 4 cancels this 4, so I'm left with an x plus 1, an x minus 4, and a 3. Everybody see that step? All right. So this step can be a little intimidating, but we do that step so that this doesn't look so bad, because our goal was to get rid of all the denominators. With all the denominators gone, Mike, yes?
Minus 4 on the end for the x minus 4. Was it a 2?
Yeah, but what is wrong with me? That definitely is a 2. Because that's what I'm why did I say x minus?
I don't understand how that x over 3 turns into 4x minus 2.
This?
Or doesn't. Yeah.
This 3 canceled this 3, so then what's left is 4 times x minus 2.
Times x.
Oh, times x. I left off the x. All right, well, visually. Yeah, probably make that easier if I write it 4x times that. Yeah, so why don't we write that 4x? Okay, so after all of my careless mistakes, okay, leaving off things, is this correct?
Yeah.
Okay. So our main goal was get rid of the denominators, and now that we got rid of the denominators, now we can go about solving this. So I'll distribute this. That's going to give me 4x squared minus 8x minus 12. To deal with this, I'm going to multiply those together, so that gives me x squared minus x minus 2. When I distribute 3, I end up with 3x squared minus x minus 3x minus 6. And anytime you see x squared and x in a number, set it equal to 0 and hope you can factor. So if I move this over, that's going to give me an x squared. If I move this over, I get a minus 5x. If I move this over, I get a negative 6. Did I do that right?
Mm-hmm. Yeah.
Okay. And let's see, to get that negative 5, I think I'm going to have to say x minus 6 and x plus 1. And what makes that 0 is a 6, and what makes that 0 is a negative 1, and so now we've solved. Sahara, I think your seat was over here, right? I have assigned seats for contact tracing.
I totally forgot.
Okay, yeah. All right. So, bumbling through a lot of this stuff, right? We still have, solve, get rid of the denominators, and you get an answer 6 and negative 1. All right. Now let's go back to this. Let's do this one. Now we did this we did this a few months ago. And how do you solve an inequality? Well, I guess, but to refresh your memory on how you solve an inequality is, let's just talk about what inequalities mean when you solve one. See, when you solve an inequality, like when you solve an equation, you get a definite answer, right here. See, I solved an equation and I got a definite answer, 6 and negative 1. Right? I got my answers. When you solve an inequality, you're getting a range of answers, because that's how inequalities work, right? And if you think about it, like if I said x less than 2, right? This is a range of numbers, isn't it? And again, kind of a picture of that range of numbers is here's 2, I'm going to put a circle, and I'm going to shade everything to the left of it. And this range of numbers represents this. And so anytime you're solving an inequality, you're looking for a range of numbers. So your job is, well, how do you find that range of numbers? Well, how you find that range of numbers is first we have to identify our boundary points, right? And it's very important that this whole thing is less than 0, right? See, because what you want to do is you want to think, well, how would you solve x minus 1 times x plus 3 equals 0? How do you solve that? Well, that's easy, right? See, to solve that, you think, well, what makes that 0 is 1, what makes that 0 is negative 3, and so we found what makes it 0 is easy, right? When you're solving an inequality, right, what makes it, those things that make it zeros, I call those boundary points. So that 1 and that negative 3, I'm going to put a negative 3 and a 1 here. And I'm going to put circles around each of these.
Should we be writing that down?
Yes, this you should. Don't worry, we're going to see like 3 or 4 versions of this exact problem. So if you don't copy it down the first time, just make sure you get it. And now if you look at that number line, notice this number line is now divided into 3 parts. So I see the 3 parts? And our job is to figure out, well, which parts work. And how you find out which part works is actually pretty easy. You test a number, right? You pick a number in here. So you pick a number in this interval. And the beauty of it is if that number you pick works, that means this area works. Or if that number doesn't work, that means the whole area doesn't work. Right? And let's talk about what work means, right? And well, it's easier to do that when we try it. So let's pick a number in this interval. Now you might think negative 4, right? But in practice, what you're going to find is picking an extreme value is actually easier. Because this is everything to the left, isn't it? So I'm going to pick negative 1,000. Now, you might think that makes it worse, but not so much. See, the fact that we have a 0 here is huge. See, if I pick negative 1,000, can we agree that negative 1,000 minus 1 is going to be a negative number? Is that easy to identify? So I know this is going to be negative. Can we agree that negative 1,000 plus 3 is going to be a negative number without too much work? And negative times negative is positive. Is a positive number less than 0? Do you see how picking an extreme value, right? You don't worry about the exact number, right? And the reason you don't worry about the exact number is you've got a 0 over here, right? And so now we pick something over here. What's a reasonable value to pick in that interval? Anytime you can pick 0, you want to pick 0. And we're still going to approach it this same way. 0 minus 1, I bet that's a negative number. 0 plus 3, I bet that's a positive number. Negative times positive is negative. Is negative less than 0? Yeah, you bet. It works. And I pick a number over here. Guess what I'm going to pick? Positive 1,000. And can we agree that 1,000 minus 1 is positive and 1,000 plus 3 is positive? If everybody's positive, that's not less than 0, right? And so this doesn't work. And so we just found out that the range of numbers that work in this case is from here to here. And so we're going to write our answer in interval notation. That's going to go from negative 3 to 1, and we use open parentheses. Does that make sense? All right. Well, how does it change if I put an equal to sign? How does that change my answer? Yeah.
If any of the, like if you put any of the values that equal 0, then that also counts too.
Right. Which means, what is that? How does it change this picture?
Just answer comes.
You fill the dots in, right? Is everybody okay with that? Like, so if I put an equal to sign, well, you've got the exact same picture. I've got negative 3, I've got 1. But now I fill the dots in. You know, if I check, it's still going to do the same thing, so I'm going to go from here to here. And so now how it actually changes my answer is I'm actually going to go from negative 3 to 1, but now I get the little brackets. Okay? So not much changed here, right? All right. Well, what if I give you x minus 1 over x plus 3 is less than 0? Remember this whole thing is about rational expressions, right? This is not a rational expression, right? Rational means I got to have a fraction, so now I'm going to talk about how do you handle this. Well, believe it or not, you handle it the same way, right? When you look at this, you've got a fraction less than 0. I want to know if this fraction is positive or negative. If it's a range, it's a range of numbers, so I still want to find my boundary points. And so when I look at this, well, what makes the top 0? 1. What makes the bottom 0? -3, right? Right? So your boundary points are exactly the same. I've got 1 and -3. I'm going to do my little chart. And so I've got -3, I've got 1. It's open, circle, so I put...
Would you not be making it equal to what's less than 0?
No. You want to find the boundary points and then find out what works. Because if you try to do like this less than 0 and this less than 0, you're not going to get the right answer. It's not what individually are less than 0, it's the combination of them. I want to know when this fraction is negative. And this fraction is negative, you can't answer that by looking at the top and the bottom individually. We have to look at them combined. No. So here's our boundary points. All right, got -3 and 1. Great. And now we're going to check. Those boundary points, they've divided this into 3 parts, and if I check, well, it's going to be kind of the same thing. If I plug in -1,000, are we okay? -1,000 minus 1 is going to be negative. -1,000 plus 3 is also going to be negative. Negative over negative is positive. Is that less than 0? No. Plug 0 in. 0 minus 1 is negative. 0 plus 3 is positive. Negative over positive is negative. Is that less than 0? Yeah, that is. Pick a number over here, 1,000. Everybody's positive. It doesn't work, and so we get this range, right? Do you see how this is similar to the other problems? And for the most part, this is similar. So my answer to this is going to be -3 to 1. Except sometimes there's a tiny little trick. Tiny, tiny, tiny little trick. And our tiny little trick, what if I do this? What if I give you x minus 1 over x plus 3 less than or equal to 0? This is where things get a little tricky. Very little tricky. Yes? Yes. Okay. So very little. We still do our boundary points. Our boundary points are exactly the same. Boundary points are 1 and 3, -3, so I put a -3 and I put a 1, right? I want to put circles. Do I fill them in?
No.
Why?
Because it's a fraction.
-3 is not legal. Does everybody see that -3 is a problem? You got 2 rules in math. You can't divide by 0 and you can't take the square root of a negative, right? And so anytime you see a fraction, you have to remember, I can't divide by 0. So what's a little tricky here is it can equal 1 because you can get a 0 on top. But it can't equal -3 because you can't have a 0 on the bottom. Now when you check, you still have your 3 intervals, you check your 3 intervals, you still get this, we're still going to get the same picture, right? We're still going to shade from here to here. But we've got to be careful. All right? So if we've got to be careful, okay, then let's see, it's going to go from -3 to 1. It includes the 1, but it doesn't include the -3.
So the 1 is filled in with the negative.
Right. You're allowed to have 1, right? You got 2 rules in math. If you see a fraction, the bottom can't be 0, and if you see a square root, the bottom, what's inside can't be negative, right? I see a fraction, the bottom can't be 0. Okay? And if x is 3, I'm dividing by 0 and bad things happen. Does that make sense? So for the most part, like, these are all kind of the same problem, aren't they? Right? You do the exact same thing. But when you have a fraction, you got to be a little careful. All right? Messed up in first period, so I'm going to try to fix that here. So let's look at a slightly more complicated problem. What if I have x minus 2, x plus 3, x minus 5, and an x? I'm tired of doing less than. We're going to do greater than.
Is that a 5?
Yes. It's my attempt at a 5. That's a better attempt at a 5.
Wait, so it's x minus 5x?
X minus 5 times x.
Oh.
If you want to, I guess I can put the x over here. All right. So how do you do it when there's a bunch of stuff? Same way. What are your boundary points? What makes the top 0? What makes the bottom 0? 2, negative 3. All right, what else? 0 and negative 5. Does everybody see those are your boundary points?
Positive.
What?
Positive.
Positive 5, yeah. Is everybody okay with that? So our boundary points are 2, negative 3, 0, and positive 5. So we're going to put those on our number line. All right, so negative 3, here's 0, here's 2, and here's 5. That's greater than, so I just put open circles. And now I have to check everything. Right? I have to check which intervals work. So how do you do that? Well, I mean, you pick a number. I'm going to start way over here. Negative 1,000. If x is negative 1,000, are we okay that negative 1,000 minus 2 is negative? Negative 1,000 plus 3, well, that's still negative. Negative 1,000, no, that's negative. Negative 1,000 minus 5, that's negative, right? Negative times negative, so our top is positive. Negative times negative, our bottom is positive. Is a positive number bigger than 0? Let's pick a number over here. Yeah, we're kind of stuck. Negative 1. Now, well, you can't pick 0, right? Yeah, because we've got that. So we've got to pick negative 1. And don't worry about what the exact number is. What you care about is just am I going to get a positive or negative number? Notice I have these 4 little things. I just care about if I plug a negative 1 in, yes?
You couldn't do negative, or you, wait, could you, never mind.
Glad I can help. Okay.
Okay, never mind.
So we're going to pick, and you can pick anything you want to. Negative 1 seems to be the easiest one to pick. So when I pick negative 1, are we okay that negative 1 minus 2 is going to be negative? And the negative 1 plus 3 is going to be positive? Then that's a negative, and then that's a negative. And are we okay that everything's going to work out to be negative? Is a negative number bigger than 0? No. I'm going to pick something over here. Probably pick 1. And 1 minus 2 is negative. It's positive. Positive. Negative. Everybody okay that's positive?
Yeah.
When you're done, isn't it? You get negative over negative, which is positive. Is positive bigger than 0? Okay, so that works. Pick something over here. Yeah, 3. 3 seems reasonable. So 3 minus 2 is positive. That's positive. That's positive. That's negative. Okay, that's a negative. When everything's done, said and done. That's not greater than 0. I'm going to pick a giant number. Everybody's positive, and that works. So I end up with this works, and this works. Okay. Now to write my answer, I'm going to have like 3 little parts. So I'll have a little part here. I'm going to go from negative infinity to negative 3, union 0 to 2, union 5 to infinity. Yes?
This is what we were just doing, wasn't it?
A little bit, yeah. Yeah.
It's like end behavior kind of thing.
Yes?
Will it always be like symmetrical? Like which
That's what I'm getting. Okay, okay. Not symmetrical. I mean, this just happened because we had like an odd number of intervals. I guess the question you want to ask, does it always alternate? Right? I think that's the question you wanted. That's what I was about to talk about. So, for those of you that like patterns and want shortcuts, 90% of the time the signs alternate, unless something weird happens. Right? And what I mean by alternate, like this is check, X, check, X, check. I don't know if you noticed it on the last example, they alternated. On this example, they alternate. 90% of the time they alternate. So you can kind of cheat a little bit. Right? Once you find out if the first one works, you can say, oh, well, just keep alternating. When does it not work, right? It doesn't work whenever something's squared. No, that's the bad news. The good news is I'm not going to give you anything squared. It's actually related. Do you remember we were graphing and there were like double zeros and things bounced? It's related to that. So if you ever see something squared, it bounces, and I could pull in pictures and all this other stuff, but I really don't want to go there. Right? Really what I want to today is, even if I give you something ugly, I went through the process of actually, hey, figuring out what works. And as long as you don't see a squared or something to the fourth or something to an even power, it alternates, right? And it will alternate for the problems that I give you. So this is, solving a rational inequality. Let's talk about what's important, right? Thing number 1, you get a 0 over here. See, with that 0, because there's a 0 here, all I care about, notice I just cared if I got a positive or negative number. Everybody see that? It was really easy to compare if something's positive or negative because I have a 0 over here, right? And actually, I guess really the most important thing was find your boundary points. Because once you find your boundary points, then you determine your areas. All right. Now, unfortunately, the problems that I'm going to give you don't look like this. Right? The problems I'm going to give you look like this. All right. So what makes that problem harder? Why is this one harder than this one? It's 2 fractions, right? You like it when it's 1 fraction on this side and a 0 on this side. Well, we got the 0, right? But we don't have the 1 fraction.
Did you make it 1?
But we could make it 1, couldn't we? Just get a common denominator, right? Make it 1 big fraction. So to make this 1 big fraction, okay, I multiply top and bottom by x, top and bottom by x plus 1. And so that's going to give me x plus 2, x plus 1, all over x times x plus 1 less than 0. Remember that stuff I made you do in December where we had to get common denominators and combine? You didn't like it, and unfortunately that's kind of what we have to do here. So we get our common denominator. Everybody okay with this part? And let's see, when I clean this up, So that's x plus 2x plus 2, so I end up with 3x plus 2 over x times x plus 1 is less than 0. Okay? So what are our boundary points?
Negative 1.
And 2 over 3.
Negative 2 over 3, right? Everybody okay? Those are our boundary points? Because we just set each part equal to 0. See, now it looks easy, doesn't it? So we're going to draw our thing. Okay, here's negative 1. Here's 0. Here's 0, and then here's negative 2 over 3. Right? I'll put little circles in. 4 intervals I've got to check. All right. Let's pick one over here. What am I going to try? Negative 1,000. All right. Now you'll start to see the importance of just caring if it's positive or negative. So 3 times negative 1,000 plus 2, is that going to be positive or negative? Is that easy to figure out? You don't have to work too hard about that, do you? 3 times big number, 3 times negative big number is really negative, plus 2 is still negative. And on the bottom, well, that's negative. Negative 1,000 plus 1, well, that's negative. Are we okay? The top's negative and the bottom's positive? And so the whole thing's negative. Is negative less than 0? Yep. So this works.
So that one doesn't. And
I mean, we could go through and try to guess plug-in fractions, but that seems painful, doesn't it? There's nothing weird going on here. Nothing's being squared. And since nothing's weird going on, we can just alternate. This one doesn't, this one does, this one doesn't.
Oh my God, I understand this.
Does that make sense? Well, now, I have to write down these two intervals. Using interval notation, I have to write down those intervals. And so this interval, well, let's see, it's going from negative infinity to negative 1. And this interval goes from negative 2 over 3 to 0. A little union there, and I've got my answer.
Could you have done this for the last unit we did?
Well, this is still part of the last unit.
Wait, we didn't finish the unit?
No, we didn't finish all of rational. So in December, we introduced, and I knew I wasn't going to finish. So I just did, because remember we solved?
Right.
Your book actually, puts solving equations and inequalities all in the same section, which I think is a recipe for disaster. I think we learn how to solve, and after we learn how to solve equations, then we talk about inequalities. I don't want to put them all in the same spot.
So you separated it into 2 units?
Yes.
Because there's 2 different sections, right?
What?
Because there's 2 different sections.
Well, there's multiple sections in here.
But in the,
Yeah. All right. Yeah, these are the 2 parts. Yeah, for that we go. Okay, did that make sense? Okay. Well, how does it change if instead of it being less than, I said it was less than or equal to? Yes.
don't they just become brackets?
Do they all become brackets?
Wait, no. The inside ones, but yeah.
No.
The outside.
Well, what's the only one? Okay. What's the only one I can include?
Negative.
Oh.
Has nothing to do with the inside or the outside. It has to do with what's legal. If this is equal, can x equal 0 or negative 1? So those stay wholes, right? But can't be the top, right? And so then what happens,
Wait, oh, so the negative 2/3 becomes the bracket.
and the only thing that actually changes is you can include the negative 2/3. Do y'all see what happened on this? Right? You can't, if I put an equal to sign, it doesn't get to equal everything. You can't divide by 0. So you still can't have 0 or negative 1.
Oh, so the only one you transfer.
So the 0, negative 1 still say hollow, right? But what can happen is the negative 2/3, right? So everything hinges back on this picture. Like, the only way you can do this problem is find your boundary points and draw the number line. Yeah, you got some shortcuts on how to figure out the shading, but you have to draw the number line and you have to draw the shading. And after you draw that, then you can come up with this. Right? There is no way to go straight from here to here. If you try to go from here to here, it's going to be wrong. Right? You have to go through the spot where you're checking. You have to check the intervals that work. Oh, so, oh, well, that was my problem. Here's yours. Like, make it look that way. Like this is over 1, so this needs an x minus 1, top and bottom, okay? And so that's going to give me 5 plus x minus 1 over x minus 1 is less than or equal to 0. All right, that's x plus 4 over x minus 1 less than or equal to 0. So my boundary points, what are my boundary points? Negative 4 and 1. And so I put this out, and I've got a negative 4, I've got a 1. I've got an equal to sign. Do I get to fill both dots in?
No.
Which dot do I get to fill in?
Negative 4.
The negative 4. And now we check. Really big negative, negative over negative is positive. That one doesn't work. So that means this one works and that one doesn't work. So my answer is going to be negative 4 to 1. I don't include this. I get to include that part. Now, this actually isn't this is an example out of your textbook, but they didn't give it to you this way. The way they gave the example in your textbook is they said this is 5 over x minus 1 is less than or equal to negative 1.
Oh, but you can just.
You see it's the same problem, right? But remember, you like seeing it equal. You like having a 0 over here. Does that make sense? So if you see it like this, make it equal to 0, and then do this same stuff. Now, last problem. What do I have? 4 minutes. Got good news and bad news about the last problem. The good news is it should look familiar. The bad news is it's harder than the first time we did it. So, what if I give you x over 3 minus 1 over x minus 2, and this one I want greater than x plus 1 over 4.
Is this the problem we did earlier?
Yes, that's the good news. Right? The bad news. That's not an equal sign. Okay?
So how do we make, or how do we make that?
So there's 2 ways to do this problem. Okay? And that's why the bad news is I've got 3 minutes and I don't think I have enough time to do both ways. There's the way your book does it and the way I recommend, right? actually, I don't even know if I recommend it anymore. There's two ways. They both take about the same amount of space, this much. Right? You know, here's method 1, here's method 2. No one's shorter, right? Right? So just prepare you, get you ready. It's to solve this is harder than solving it if it's an equal sign. Right? There are some tricks, and again, I don't know if I can get through all the tricks in one. So one way is I like seeing one fraction on this side and a 0 on this side, right? Because we know how to handle that. And so what I'm going to do is we'll just move this over. So this is going to give me x over 3 minus 1 over x minus 2 minus x plus 1 over 4 greater than 0, right? And now I'll basically get one big fraction. Get a common denominator, right? That's one way to do this. And in the interest of time, so that I can actually show you the second way, I'm going to go through it. I'm going to do it quickly. Hopefully correctly, but you know, the same thing. So let's see. This one's going to need a 4 and an x minus 2, 4 and an x minus 2. This one's going to need a 3 and a 4, 3 and a 4. And this one's going to need a 3 and an x minus 2, and a 3 and an x minus 2. Okay? That way I can get all the denominators the same. So my denominator ends up being 12 x minus 2. And on the top, let's see, that's a 4x times x minus 2 minus 12 minus, let's see, minus 3, and ends up being x squared minus x minus 2, which is 4x squared minus 8x minus 12 minus 3x squared plus 3x plus 6. And again, apologize for doing this quickly because normally make you do this, but I've only got 30 seconds, and so I'm kind of stuck. Minus 5x minus 6 all over 12 times x minus 2, and all that's greater than 0. You know, after a fairly ugly step, now when I factor this is going to give me x minus 6, x plus 1 over x minus 2 times 12 has got to be greater than 0. And we can solve this, right? Everybody see our boundary points? And since the bell's about to ring, I'm going to end there. I did give you some homework. It's out of your textbook. I've actually already put the problems in OneNote. Attempt them, all right? Try all of them. I'm going to show you method 2, which is the way your book does it tomorrow.